Question 16. A, B, C and D are points on the circumference of a circle, so I'm thinking, is there any doubling or halving to be done? Centre O. Centre circumference, that quite often says let's double or halve, but this is not that one. AC is a diameter of the circle. Now there's a key word used there. The diameter cuts the circle into two equal semicircles and does say must show all your working. The angle in a semicircle is 90 degrees. Knowing that, we could do 90 add 25 at this angle here, must be 180. 90 add 25 is 115, take that off 180, we've worked out that this angle is 65 degrees. If that's 100, this also would be 100 degrees in the exam. If it said give reasons for your answer, I would say vertically opposite angles are the same. And there's a lovely straight line here, so this must be 80 degrees. 100 plus 80 makes the 180 degrees. And to finish it, I could put 80 there as well. Vertically opposite angles are the same. I'm now focused in on this triangle here, C to B to O. I've got a 65 and an 80, which add up to 145. They're supposed to add up to 180, and the complement of 145 to get it to 180 means this angle down here is 35 degrees. Now I don't know if we can see what I'd call a bow tie angle here. We can see a bow tie, that means the angles at the top must be the same, so if that's 65, that will be 65. And the angles at the bottom of the bow tie would also be the same, so if that's 35, that is 35 degrees. Angles in the same sector are equal. Please write that as a sentence in the exam. Work out the size of angle D to A to C, answer 35 degrees. And then we have some circle theorem proofs, and I'd like to do more circle theorem proofs than there are just here. Prove that the size of the angle A to B to C, I'm not sure what that is, so I'll call it X, and angle A to D to C, not sure what that is, so I'll call that one Y, is 180 degrees. Now with circle theorems, it's quite often to do with drawing straight lines. We know, and we can quote one of the circle theorems here, the angle at the centre is double that at the circumference. I would write that as a sentence in my exam. And if that's Y, then this angle here will also be 2Y, again, same reason. The angle at the centre is double that at the circumference. Now we know, because angles around a point add up to 360 degrees, that 2x plus 2y must be equal 360 degrees. And if I halve both sides, we get x plus y is 180 degrees. There are some more circle theorem proofs that we need to be aware of, and we'll cover that later in this